Sophisticated monitoring stations like this are sprouting like weeds throughout Nevada's Great Basin and Mojave Desert. Funded by the National Science Foundation EPSCOR Nevada Climate Change Project, scientists are using the stations to study the possible effects of climate change on the state's ecological systems and water resources.
The Nevada ecosystems are extremely interesting. It's really one of the best places to study climate change because of the very low impact from human population outside of the urban centers.
5 sites in the Sheep Range and 7 sites in the Snake Range are strategically positioned to form transects, a scientific term that describes a strip of land from which measurements are taken at regular intervals. These measurements form a baseline from which responses to changes in temperature or precipitation may be noted.
The transects have a special feature, which is they go from the valley all the way to the top of the mountain and over in the Snake Range. So we are very interested in elevational gradients. And so one thing, that, for example, that we are studying is how the plants at various elevations respond to changes in climate, and how the phenology of the plants changes from the sagebrush valleys all the way to the bristlecone pine forest on the top of the mountain.
Obviously, if there's warming, you're going to extend the growing period. And so you take a species like the bristlecone pine. It has evolved over millennia with a very limited growing period that's in balance with the resources available. And so now you extend the warming period, and it's going to perhaps not be able to continue to grow because there won't be the water resources and the nutrients that would allow for an extended growing period. Everything is linked together. You change one thing, you change everything.
To measure these changes, each site is equipped with a variety of sensors and monitoring devices. Some even include webcams that routinely scan the area surrounding the site.
On each of these stations, we will be measuring atmospheric variables, hydrologic variables, and ecological variables as part of the baseline data set that we're developing. And some of these sensors will be on the tower that's going to be in the center of the site, and some of these sensors will be on the ground or in the ground, and other sensors will be attached to vegetation, such as trees, conifers, some shrubs.
We'll actually hook up probes on the plants and actually measure transpiration, water movement through the stems. We'll have sensors over the plants that can assess growth and development and the overall health status of the plants.
One of the unique aspects about this project is that in addition to the basic set of meteorological sensors at these towers, we have a set of plant and soil sensors as well. And so this is allowing us the opportunity to not only monitor the amount, timing, duration, and form of precipitation coming down in these 2 areas of Nevada, it's also allowing us to assess the fate of that precipitation. Is it going into surface soil moisture storage? Is it percolating deep within the soil profile and going into recharge into our basin aquifers, or is it being transpired by the plants?
Sites are located at different elevations, close enough to form a transect, but far enough away to support new vegetation. The Sheep Range transect, for example, begins on the creosote-dominated valley floor, moves through the black brush, pinyon and juniper trees, ponderosa pines, and ends at Hayford Peak, a subalpine area.
That's why we're placing these towers at multiple elevations but in the same mountain range, so that we, within a close spatial proximity, can look at some of these different environmental variables across different elevations and start the baseline recording. So if we can, the longer we keep track of these variables, the more valuable that data becomes, because then we can look at it over the longer term. So this is the northern transect in the Snake Range, and it's more in the middle of what would be called the Great Basin Desert. So the environment here is quite a bit different than it is down in the Sheep Range in the south. And so here we have quite a different species mix. The seasonal climatic regime here is quite a bit different than what they have down there. And what we're building here are the very same systems that we have in place in the sheep transects and in the spring transects. The tower will be 10 meters tall, so it will actually reach up into the top and probably above the canopy for the most part. And that tower will have all of the atmospheric sensors on it, as well as radiation sensors. And That tower will have our communications equipment on it, and we'll have our web camera on it as well. Where I'm standing now is going to be the core of the central power system. So this is going to be a large solar panel array. We're going to be putting in 4 footings for that, and then an array very similar to the ones that you've seen elsewhere down in the Sagebrush site, for instance. And this power system will provide us power not just for the station that we just pointed out, but it will also power vegetation sensors that are going to go out on some of these trees around us, where we will be able to monitor the seasonal growth of these trees and their response to some of these precipitation events and temperature changes that we see on a seasonal basis. So where Brian's standing is the hole that is going to be the foundation for the snow and rain precipitation gauge. The GNOR precipitation gauge does a fairly good job at recording both snowfall and rainfall, and that's going to be sitting right here on that pedestal. And that gauge will give us a very good idea for how much water is actually being input into the system on a seasonal basis.
By the end of this summer, by the end of this year, we'd like to have all of the sites 90% or 100% functional. Well, we have to take it, one day at a time, basically. It depends on the weather and if we can get to the sites. There's an enormous amount of resources that have to be brought in by hand. You can't just simply call a cement truck and have it delivered. We have to bring in by truck, 4-wheel drive to some of these upper sites, all of the water, all of the concrete. For the PJ site today that we're going to be putting in, we're bringing up approximately 3,000 pounds of concrete and 1,000 pounds of water.
Measurements from the 5 sites in the southern transect are taken every 30 minutes and stored on servers at UNR. Scientists access the data through a web portal specially designed for this purpose. Measurements from the Spring Valley will be sent to a repeater on Cave Mountain, then to Great Basin Community College, and finally up to UNR.
Once the Cave Mountain repeater is in place, all the sites in the valley and in the Snake Range will be able to communicate out. On the west side, in the Snake Valley Range, we'll have a similar repeater at the Elksdale repeater location that will send the data out through the Utah network and eventually to the Reno cyber infrastructure.
We've got implementation, we've got installation of the equipment, and so now the exciting part comes in to distribute this data, to open up the floodgates, let this data kind of out into the scientific community, and to start teasing out some of these relationships.
We were very fortunate to get the EPSCOR funding to put this in place, and now again our goal is to take advantage of that, to leverage it to where we can compete with other universities throughout the United States and get funding to be able to ask questions that have relevance not only on a national and global scale, but also to our state.
I think this is a tremendous project. It's very exciting because of all the sensors, the unique collection of people and science being brought together. I am sincerely hoping that we just get a much bigger picture, if you will, of what's happening. These 2 transects are monitoring specific points over time, but using remote sensing, which is something I do and others in our group, we can extend that spatially so we get a better understanding of the dynamics happening in this dry environment.
For more information on this project, contact Lynn Finstermaker, Franco Biondi, or Dell Devitt, or visit the website nvclimatechange.org.
The preceding program is made possible through support from the National Science Foundation, a production of UNLV's Hank Greenspun School of Journalism and Media Studies and UNLV TV.